Hello, the topic of this talk is fantastic facades and how to build them. My name is Surapong Lertsithichai from the Faculty of Architecture, Chulalongkorn University, based in Bangkok, Thailand. This research is an ongoing investigation in augmented architecture, which explores a new type of facades that are seamlessly integrated with the architecture, enhanced with multiple functionalities, interactivities, performative qualities, used to extend the building's use beyond its time lifespan. Fantastic Facades was an option studio offered for Year 4's architecture students. This was an investigation for a period of 1 semester or 4 months. The process involved a lot of form generations, experimentations with 2D and 3D techniques, inspirations from nature, including biomimicry and generative designs, biomechanics, leaf stomata patterns, porous bubbles, origami folds, and so on. Eventually, throughout this process, there were 5 facade designs that were carried on from the beginning towards the end, where the students were required to integrate these facades in an actual context in an existing building or structure based in Bangkok. The facade design process included 5 steps, which were the facade research, looking into existing building facades. Students had to do analysis of these existing facades. Secondly, form generation, explorations in biomimicry, parametric creations. Thirdly, surface system, the modular and multi-layer surfaces and secondary structures to support this form generation. Fourth is performative interactions, which would include interactivity, meanings, and kinetic movements. Lastly, contextual program. Students would be looking into site requirements or take some cues from the context and develop and integrate the facades into an actual building. So here are some design facades that were looked into: the Arab Institute, Heatherwick in Shanghai, Garden by the Bay, and Calatrava Station. The process of form generation by some of the students, this group was interested in porous surfaces, so they experimented with molten aluminum, and they would pour this into a structure or a frame, a mold. Inside they will have gel balls that would melt after the aluminum is poured inside, so leaving gaps in between. Here are some images of the process and the end result, as you can see the far right. Next is a group that was interested in biomechanics, specifically in animal movements of birds and the wing flight patterns. So they would make biomechanics that would mimic these. All of these joints were designed physically and then transferred into Grasshopper. So here in Grasshopper, the students would tweak some of the variations of the radius, length, and so on to create a continuous line that would form a 3-dimensional surface. That was tweaked until it could be able to wrap around a surface of a building. This group was interested in the leaf stomata, which is basically the openings and closings behind a leaf surface, allowing for air and water to be released. So that opening and closing was interesting to the students as a pattern. They mapped that out into a geometry and eventually extruded or created this 3-dimensional surface inspired from the pattern. This group was interested in surface transformations that were two-dimensional and could create a three-dimensional effect, in particular origami. And their exploration turned out to be something experiment with surfaces that were interactive. So it would change its form, hence the term transformations. Throughout this process of surface system, creating a unique surface requires some kind of complex geometry of a supporting structure. And this might not be a standard industrial standard that you could see or simply borrow from construction. So students had to come up with a novel way of supporting this surface, and they had to explore different materials as well. The performative interaction was considered after the fact that the feasibility of a facade and its supporting structure was could be realized. And the next thing they had to consider was the functionality or the aesthetics of how the facade will perform, whether it has some kind of meaning to its users or its surrounding. So students had to create a prototype to demonstrate these functionalities or interactions in specific scenarios. And they were introduced for the first time how to use Arduino, using inputs and outputs that differ for different scenarios. Lastly, all projects that were transferred over to the last phase, which is Contextual Program, they had to seek existing buildings or abandoned buildings or structures and convert them into a functional architecture with a interesting program. And then integrate the facade they've designed to have it match with this context. So we'll go through the projects briefly. There are 4 projects that have been selected for this presentation. The first project is called the Artificial Lung Facade. Second is a Theater Performance Facade. Thirdly, a Sound Activated Facade. And lastly, Emotion Mapping Facade. The first facade is this artificial lung. The group that was interested in the leaf stomata developed this into an artificial lung. So the idea was to take in these poor quality areas of Bangkok with heavy traffic jam. The system or the facade on existing bridges or surfaces of the building in the area would filter out PM 2.5 and other pollutants in the area and release the filtered clean air to the air. And this was a prototype that they developed using
so you can see it from this
the Arduino
LCD. So it shows like the dust value is
into the
like around 580.
There's a detector that detects the smoke, and the pump would automatically activate and filter the air in the chamber through a HEPA filter. The next project is a theater performance facade. This is an interior of one of the well-known theaters that has been preserved for over 50 years in Bangkok. This is the Scala Theater. The student was inspired by the patterns in this Art Deco style building. And what she wanted to do is to take those elements of decorative panels and make that into for the exterior facade. So covering it with this flower-like panel, if you like, and it could be used as an external fan to help with ventilation, and it also would create these patterns of movements throughout the day and night. Third project is the sound-activated facade. Students came up with a proposal for an existing manufacturer of speakers based in Bangkok called One Systems. They wanted to use their showroom as a way to promote their products and their capabilities looking into sound. So the student was inspired by how sound could interact with a surface and how that would change or transform that surface dynamically using sound. So he would look into substructures that would be flexible enough for panels that could be twisted or could be moved. And he came up with a prototype connected directly to Grasshopper.
Yeah, you can see it, you're perfect. So it's basically like
and
responding to the
sound audio input.
And in this case, it's just got a
and directly transforming into movements. Lastly is this emotion mapping facade. This is an existing museum in the heart of Bangkok called Bangkok Art and Culture Center. The student wanted to walking within the building. When they see the artwork, they would either have the 5 basic emotions mapped through the face. All of this was using Grasshopper with additional plugins to capture a video from the laptop, and that was translating to colors by emotion, and emotions would help activate the facade to move according to that emotion. Other projects
in combination, so that goes up, this goes down, and this will create
more kinetic,
a kind of openings that when
could be developed further. So lastly, conclusion, we see that the process of building facade definitely does not fit in the duration of 4 months. Would require more refinement. But the most productive aspect of this procedure is the creative process of form generation. The students found that to be very interesting and applicable to other processes of design. The building prototype was also something that they used to test out features, and was also something that we were interested in pursuing in the future. So future work would be to create a similar process like this, perhaps shorten the process for some of the research and building more. Testing and prototyping would be more beneficial to students. And these are acknowledgements. Thank you very much.